The next rule we learn about is called implicit differentiation. Now this rule is rather cool. So I think this is the first one of all these many rules we have, which is indeed a tiny bit more complicated, because the function you are differentiating is only defined implicitly, but you still can find the derivative. So let me show you how this goes. First of all, an implicit function is a function y equals f of x, which is defined by an implicit relation. So of the form h of x, y of x is equal to 0. So in many cases, we can actually not write it as y equals f of x. We can only write it in this implicit form. So here are two examples. So for example, the unit circle is an implicit function. Right, so you have all points x and y, so that x squared plus y squared is 1. This is a unit circle, and you cannot write the unit circle in this form, because for each value of x, here for example, you have two values of y. Still, it has a nice graph, so we might be interested in the derivative, y prime of x. Here is another implicit function, x sine y plus y squared equals x squared. So it can be more complicated than the circle above. And again, the question is, how do we find y prime? The rule is as follows. So to calculate the derivative y prime of an implicit function, the idea is to differentiate both sides of the equation by x. Use a chain rule and then solve for y prime of x. So this can only really be explained by examples. Let's do the two examples which I just had earlier on the slide. For example, the unit circle. Find y prime of x along the unit circle. First thing we do is we agree that we are really interested in this implicit function y of x. And then we rewrite the unit circle equation using y of x, okay? So we have x squared plus y of x squared equals 1. And now it makes sense what I wrote up here in blue. So differentiate both sides of the equation by x. Let's do that. d dx x squared plus y squared equals d dx of 1. And then we use the differentiation rules which we know already. So for example, d dx of x squared is 2x. d dx of y of x squared, so to be very clear, maybe I put another bracket here. And then you see this is the chain rule. So the outer function is the square function. So we get 2 times y of x, and then times, now the inner function is y of x. It still depends on x, and the derivative is y prime. So I use the chain rule as described up here, and I get y prime coming out. And then on the right hand side, d by dx of 1 is of course 0. So now I have an equation where y prime arises, and I can solve it for y prime. So I do 2y prime equals minus 2x. Okay, I move the 2x to the other side, and then I solve it for y prime. So y prime then is minus x divided by y. So indeed, I do get an expression for y prime, but this expression includes y on the right hand side. So it is, again, implicitly, it is not explicit. Still, we get a very cool expression for y prime, which is minus x divided by y. Let us do the more complicated example on the next slide. So x sine y plus y squared equals x squared, using implicit differentiation. Again, we assume y depends on x, and then we differentiate both sides. d by dx x sine y plus y squared equals d by dx x squared. And let's do the same story as before. So differentiating x sine y requires a product rule, but then y depends on x, so then there we also need the chain rule. So we need product rule and chain rule at the same time. Let's do this stepwise. So that term, if I differentiate by x, I keep sine y, and then plus x times the derivative of sine y, plus 2 times y, which is the outer derivative, times the inner derivative, which is y prime. And then on the right hand side we get 2x by the power rule. So then we only need to worry about the sine y term, plus x, so the derivative of sine y, now sine is the outside function, derivative is cosine, cos y, but then times the inner derivative, which is y prime, plus 2y y prime equals 2x. You see, we had to use a chain rule twice, for this term and for this term, because y depends on x. But now we are basically done. So now we just need to sort it out and solve it for y prime. Let's move the sine y to the other side. And then we have x cos y plus 2y. All this times y prime equals 2x minus sine y. Great. And then we get y prime equals 2x minus sine y divided by x cos y plus 2y. Ta-da! We have a formula for y prime. Again, the formula includes y on the right-hand side, but still, it is a cool formula. Here we go. Let me summarize this. So we got one more rule, which is the rule of implicit differentiation. Here it's difficult to write down a formula, so I rather write down the strategy we have to use. So we differentiate the equation by dx, we use the chain rule, and then we solve for y prime. Oh, Professor Dumbledore. Nice to see you.
Hello, Dr. Hillen. I have a very old pensive here, which can create implicit functions. Let me show you some.
Oh, nice. Oh, yeah, this is also nice. Beautiful. Ta-da!